Alright guys, today I'm going to be showing you a tool I've been working on. It's called a Rivnut tool or rivet nut tool. We use these quite a bit at work and need to replace them occasionally, and the tool that you can buy online, or the one that I have, looks like a big pair of bolt cutters, and it's really bulky when you're trying to get into tight spaces. So I saw this design online by a guy. His channel's called the Aussie Shed, and I'll put a link to it below to the video of the one that he made. Mine is very similar to what he did. I really like the simplicity of design, so we're going to give it a try today. The design is pretty simple, as you can see in the drawings here, but as you'll see later on, I'm pretty good at screwing things up, so it'll be fun to watch, I'm sure. I have all the basic design elements here in the drawings and only wound up using the internal dimensions, as I like the finish of the bar that I bought and didn't want to turn it all the way down to the finished dimensions in the drawing. And those external dimensions are not really a big deal. It was mainly the internal ones that really make the big difference. So I left the outside dimensions pretty much like they were on the bar when I cut the stock out. So this right here is, they call it a post hole digger. I got it at Home Depot. It's about 40 bucks, and it gave me a lot of steel to work with later. It's a strange looking post hole digger, but it's basically just a big heavy piece of steel that has a sharp end on it for chopping out hard clay. But basically I went in and I took it and I cut it down in half to about where the dimensions started getting close to the size that I wanted. As the bar is tapered, if you can see, it's kind of fat at the bottom and then it gets narrow at the top. And then I went in and cut a little piece off, a little bit oversized to the drawings, and got started from there. So here I'm turning down the face of the piece that I cut off. I was going to turn it down to the dimensions I had in the drawings. The length was going to be about 1.5 inches, or it was 1.5 inches. But I just wound up turning it down until it was square on each end. I figured I'd make up the difference with the length of the bolt, because it'd take a long time to take off the amount that I had left on this, because I don't have a fixed saw to make perfectly square cuts. It takes a while because I don't get really close to the dimensions. That's something I need to work on in the future. So here I'm getting my compound set up to cut a 45-degree angle. I'm just running it back so I can get to the bolts underneath to adjust it. But you'll see I set it for 45 degrees, and then I'm going to chamfer that end off like it calls out in the drawings. As you can see right here, it's calling out for 312 thousandths. Here I'm going ahead and drilling a small hole to accommodate the M5 threaded stud that pulls the rivet in. This clearance hole is to be 195 thousandths, which is basically the closest drill I had that was larger than an M5 bolt. I really should have done this from the other end so I could leave this setup alone and do both holes. As you'll see, I had to flip the part and drill the larger hole, and I lost concentricity. It worked out okay, but I would have liked to have left it as one setup. So here's where I start to run into trouble. Because I flipped the part around, I thought, yeah, I'll be able to get this line back up and get the hole concentric. I'll just slide the drill bit up in there. Well, yeah, it didn't work out too well. As you can see, when I put the dial indicator on there, that thing is wobbling all over the place. I finally got it to, I think, between 1 and 2 thousandths run out, but it wasn't perfect. But in the end, it worked out okay, but it added a lot of extra time to this setup. You can see a lot of wobble in that head right there. So did you catch that? That says 880 thousandths. If we go back to the drawing, it's supposed to be 188 thousandths. So that was almost catastrophic. But anyway, as I was going along, I caught my error, and I went back and checked the drawing before I got too far in, and went back and reset it to the correct distance, because that the hole had been too deep. I would have been in serious trouble. So now starts my second set of errors. Go ahead and turn this bolt down. This is a 3/8 bolt, and what I'm going to do is I'm going to turn this end down to just under 5 millimeters. I know the major diameter on that calls for 5 millimeters, and I usually turn it down a little less. That way it threads a lot easier. But if you notice, that's a bright bolt. It's not a grade 8. Yeah, this is going to come back to bite me later. But anyway, I go ahead and turn this guy down to the major diameter. I think I get it down to 4.83, I think, just under 5 millimeters. And if you know, I don't know if you can notice or not when I'm taking the measurements. I'll show you the measurements as I go along. But my lathe, I've got an alignment issue. I'm turning a little bit of a taper. So generally what I have to do on something like this is turn down at the small end to the dimension that I want, and then touch up the other end, and use a file and bring everything into dimension. But you'll see here, like I said later on, this is going to cause me some issues. I'm not even going to get into when I crashed the lathe and trashed the part and had to start over. So here you can see I start putting it together. And because I didn't go by the original drawings, the depth doesn't match. So it's not, the M5 is not sticking out enough because I didn't drill deep enough down into the piece, because the piece was longer than what I called out for. But yet I used the original measurements, as you saw in that other part where I said it was 188 thousandths, so it wasn't deep enough. So I'm just going to have to take it over here to the milling machine, set the DRO up and check it, and then I'll drill it to the correct depth so that I have enough sticking out. So now I've got the hole deep enough, and you can see it's sticking out plenty now. So I think we're good. We're going to head over and get the die on it and get the threads on it. So at this point, everything's looking really good. As you can see, the Rivnut fits on there really good. It's screwed up on there well. I didn't like how when I cut the bolt down, it seemed like it relieved a little bit, and it tried to bend a little bit. But so far, so good. Looks like it's going to work well. So now we need to get the handle put on it so we can actually use the thing. So what I'm doing here is I've just got some mild steel 1/2-inch round bar. It was a piece that I'd used for something else, doing a test. I just lopped the end off of it about 45 degrees with the saw. Nothing spectacular, nothing precision. Just tacked it up on there. Once I got it tacked in place, I'm just going around and welding it in good. This is a terrible little welder. It has, you can adjust the wire speed, but you basically have 2 heat settings. So it's really hard to get that thing dialed in to make a really nice puddle. But it works good. It put a clean weld on it. I got it cleaned up. This is just flux core, so clean is in the eye of the beholder. I had to do a lot of cleanup work afterwards because of all the flux and the nasty spatter everywhere, but it came out really well. You can see the end there. It's got a big hole in the end. That's where I had a center on it when I was doing some test cutting on the lathe. So because of the welding process, I had to skin off some of the powder coating so I could get good penetration and less contamination and that kind of thing. So it really kind of defeated the purpose of me leaving the finish on it, because it's a really heavy duty finish that came on that bar. But anyway, what I wound up having to do is spray paint it afterwards and clean it up. And here you can see me just going through trying to polish up the surfaces a little bit. It really didn't turn out that great as far as the finish, but this is going to be a working tool, so I'm not too concerned about that. But it looks kind of neat with the two-tone on it. So I'll go ahead and go over everything with a little sandpaper here and try to clean up all the edges and make sure I don't have any burrs and shine it up the best that I can. So once I get all this done, go ahead and test it out. And this is where the failure comes in. So now I've got my test material all set up. I'm getting ready to put this thing in. And it seems like it's going to be pretty good here. It's a little hard to get it straight there, but a little fiddly. I think it'd be better to use a socket on that, the head of that bolt. That way you don't have to hold the wrench in perfect spot. But I didn't feel like going out to my truck to get my sockets. So anyway, it starts going along pretty good. Feels like it's pulling in pretty good. It's getting nice and tight. So it's doing its things, doing what it's supposed to do. Right up till it gets to this point right here. See the end of that bolt, how it's starting to bend? That's because it's not seating in the hole correctly and it's bending the bolt. And the more I tighten it, the more crooked it gets on the end and the more it's bending that M5. Now, at first I thought this problem was because of the hardness of the bolt, but after going back and looking at the video, I think it's the way that it's seated in there and it started pulling it crooked. So then I continue on. It's going along. And man, look how crooked that is right there. So I bet you can guess what's about to happen. So I think what's really going on here is that hole was just a little bit too big. And so instead of mushrooming on both sides, I think what it did is started pulling up in the hole. And when it did, it started bending the bolt. Now again, this should be a grade 5 bolt, but that going in crooked like that was definitely a problem. As you can see, it's pretty gnarly there. I'm just showing you what the bolt looked like after I snapped it off. So anyway, I took a trip up to the local Ace Hardware, went to the bolt bin, got me a couple of grade 8 bolts for about $74 a piece. Not really, but I think they were $1.79 a piece or something like that. But hey, Home Depot don't have these, so Ace Hardware is where it's at when you want to get fasteners like this. So anyway, I'm just going to go back through the turning process again, get it turned down to an M5, get the shoulder turned on it, take it off, and then cut it to length and get it to fit back in there, and then we'll try it again with the grade 8. And another thing that I figured out later, and you'll see after I try it, I think what the problem is, a lot has to do with the thickness of the material I'm using, and I'm using the nutserts that came in the toolkit instead of the ones that I purchased aftermarket, because I'm out of those. I used them at work. But I believe what it is the ones that I've got, 1/8 inch material is too thick for them, because you'll see when I'm actually successful at getting the thing in there, it still isn't 100% correct. And that's because I believe those things shouldn't go over a 1/16 of an inch with the ones that I bought, so I need to buy some that'll go with thicker material, because as you'll see when I actually put it in the thing next time, it's still not perfect. All right, so we're going to go through the threading process again, get the M5 stud all threaded up and ready to go, and then we'll give it a shot again. All right, so we got that all finished up. Now we're going to give it a shot here. Like I said before, I think I want to use a socket on that cap up there. It's pretty fiddly right here. It's not really that bad when the camera's not in the way, but I do still think it would be a lot better if you just had a socket wrench up there on the top. So these are the screws we use at work typically on these for a product that we have. And as you can see, and I'm struggling with my left hand there, but it threads in just fine and it seems to work just great. So pretty much this has been a success. Now to the not so pretty part. You can see it looks nice and clean on the front side, but if you look on the back, it's not mushroomed out around. What it did is it pulled inside and then expanded because it's not made for material this thick. So I believe if I get the right nut certs, this is going to work great. But even in this situation, it worked fine. It's kind of weird that it worked, expanding inside of there and not destroying the threads. But like I said, once I get the right size ones, I think we're going to be on to something. And when I get that straightened out, I'll post a follow-up on it to show how it worked out. So that's it for this time. I hope you enjoyed the video. Hope it helped some people out there, maybe gave you some ideas or something like that, some things you'd been thinking about, and hope you found it useful. I really enjoyed making it, and I hope to see you again.